Good morning, good afternoon, everybody, and welcome to the Parasoft Summit. I'm very happy to be invited again here to give the keynote. And my speech today is going to focus on revolutionizing software testing. And that's happening right now, as you will see. And it's all about the power of generative AI with what we call in Forrester TuringBots. So let's get into it right away. Now, of course, maybe this is not the best time to talk about growth and innovation. We see some turbulence in the market in 2023, but guess what? What this data shows is that despite that turbulence, software still dominates the tech spend. And why is it that the tech spend is focusing so much on software as the biggest area? Well, because software is the core technology of digital, right? So digital refers to business models with technology at the core, and that technology at the core is software. So that means that software is an expression of the business. And the more you can express your business with software, right, you become a truly digital business. You can quickly implement, if you can quickly implement and improve all of your policies, your processes and procedures in software, you become, a leading organization. Now, of course, this doesn't necessarily mean only that you need to build tons of software, right? We are building more and more software, but it means that software that you build and that you've built and that you maintain has to be of high quality these days, just, more than ever these days, because that software, as I said, represents is an expression of your business. It enables your business so much that it has to work perfectly well, right? And so when we think about the turbulence, yes, you're going to be doing cost optimizations, and your CI, if you're a CIO or if you're an app dev leader, but if you're a tester, a test lead, you will think about cost optimization, but that cost optimization has to be a smart optimization, right? Because you want to be ready for the better that is ahead. We already know that, by the end of the year, perhaps things are going to improve and you don't want to be left behind. So that's not going to stop us from keeping innovating, or at least the leading organizations. It's not going to stop the leading organizations from keeping innovating fast. And so what that means from a research perspective, what we're seeing is, we've been writing a lot in the past few years about the software, the modern application development model, right? Which is this flywheel of innovation that has been going through development teams, where we're working in a more iterative way. You're using and adopting Agile. You're automating more your development process with DevSecOps and being more secure about it. You're probably adopting in some of your areas low code among your citizen developers. In other words, augmenting your capacity so with business developers that can now write their own code to do some things. Collaborative work management, new tools and new practices, especially because we're very much spread and in distributed around the world more than ever, thanks after to the COVID, with hybrid offices and so forth, and structures. And last but not least, with value stream management that focus on business value. In other words, all the software we write and we build, just as I said at the beginning, has to be something that is tightly related to business, right? So we need new techniques like value stream management to make sure that we can measure that and that we can monitor and manage that, the development of those systems, and make sure that we are scaling that development throughout the organization. Now, in that context, that's the context where continuous testing is becoming, and has become more and more a first-class citizen of modern application development and of any type of software development lifecycle you might be thinking of, right? So basically, continuous testing, and we've been writing about continuous testing. I've presented already continuous testing, I think even at this event in the past years, is is basically making sure that as we go through all the steps of your software development lifecycle, we're testing at every step, we're automating in that as much as possible. And the goal is to produce and generate that high software quality that I talked about at the very beginning, right? So continuous testing is a big reality. And really, it's very strategic, right? It's at the core of the strategy of a modern development organization that does aim at having the quality that is needed in its software, in the packages, in the software, in the applications and the products that it builds. And what this means is really, as I said, focusing on improving business value, right? That's what a modern development organization does. It is working in a continuous and automated way. Automation is key because we're trying to deliver software very quickly into production. And the only way to do that is to automate those steps, right? To make sure that we're not manually doing work or we're trying to eliminate as much as possible manual intervention. We have to do that with a certain level of scale. We're talking business value. We're talking expression of the business. These are not small, tiny apps that people are using just for their day-to-day work. But this is, enterprise software that is mission critical to your organization. And normally, that means it's going to have to scale. It's quite complex. And all of it is becoming smarter and smarter. And that's, of course, the reason for that is because of artificial intelligence, right? And therefore everything that we're doing is becoming much more smarter. But where are we today? Well, this is kind of a qualitative breakup that I, like to look at the maturity of the market in the testing, in the continuous testing space. So organizations are in a journey moving from beginners to intermediates, then from intermediates into advanced. And if you look at the market, and this means that really the beginners are kind of, are still very manual. They're early in the journey of modernizing their testing practices. They still, have user acceptance as a last step drama, as I say here, just before deployment, with no real feedback from production because it all happens at the end instead of at the very beginning. There's silos and there's quarterly or even a lot more than quarterly releases or fewer. And the intermediates start doing a bit better in terms of automation. They move that automation gap, from automating only 20% perhaps to up to 50%. They start doing API testing. They start doing all the cool practices we know about continuous testing. They're on a journey of shifting performance left, not just testing overall. They start and they start having shorter release cycles all the way to the advanced folks, which have higher levels of automation between 50 and 80%. They're doing all the cool stuff, right? A/B testing, feature flagging, chaos testing, crowdsource testing. They're releasing monthly, weekly, or even daily. They are using already AI and machine learning in the testing space. And so when you look at the market, the way I see it is really we're kind of right in the middle between beginners and intermediates. And if a broad split and the percent of companies that are in each one of these segments, it's more or less 10-15% are beginners. The other 10-15% are advanced. The big chunk, 60-70%, are intermediates, and the bulk is right in the middle between beginners and intermediates. So we've done quite a bit. We have improved, but we still need to do more. We still need to get much better. What this shows is that just modernizing testing is not enough. Modernizing testing, modernizing development, we need to do a bit more. And actually, I think we need a huge disruption. And guess what? That disruption is here already. What is it? Well, one of the things that we're seeing is that the testing technology is becoming more of a platform where you've got multiple types of testing and other things that we will see in a minute. But this data here shows you that in the last wave that I did, and you should go on Forrester, Forrester.com and look for the wave of 2022, you'll find out that we had 41 reference customers that are customers of the top 15 vendors. And when we asked them the question around best of breed versus platform driven, you can see that 28 responded platform driven by all means, and only 13 said, well, we are okay with best of breed tools. Now, what does it mean to be a platform? Well, it means, or a continuous automation testing platform. Well, it means basically, as I was alluding a bit to, is having different types of testing in the platform, right? The core and the central strategic pieces, of course, around functional testing done at the API level, but also, through UI, graphical user interface automation, tools and other approaches. You have to have an authoring environment. You've got a test environment. You've got a test data management capability. You've got service virtualization, load performance testing, reporting, analytics, insights. And basically, the goal of the platform is to kind of provide a very collaborative environment between all the different types of testing that needs to be done around functional testing, and also a uniform and great experience, right? So that I don't feel that I'm getting in and out from a tool and then jumping into another one and cutting and pasting maybe in on a board to then later use that data and bring it into another tool and do import, export, but everything being kind of integrated. And integration is key. Integration into other tools in the software development lifecycle, right? For example, key integrations are with CI/CD servers. Now, not all the platforms come with all this software integrated or built by one vendor. Some of the tools, platforms are basically an integration, a strong integration, and partnerships also help form a good continuous automation testing platform. But this is really the trend, that we're seeing on the technology space for testing, because this is where you can optimize the different types of tests that you need to do. There's 7 or 8 types of tests, right? From functional testing, non-functional testing being performance, security testing. You need the test data management. You need to integrate testing end to end. All these different types of testing. It's very nice to have this experience and usability that looks the same, and where different types of testers can collaborate. But not only the different types of testers, also the developers, right? The people, everyone in an agile team will be around the platform to do bits and pieces of testing in a very iterative way. Now, I've already said this basically, right? That why do you need a testing platform? Well, because we know, and this is not new, right? We know that testing takes a village. Right? What does it mean? It means that an organization will have different type of testers that they need to tap into test their different, when they have a huge portfolio of different types of applications. Sometimes even the same applications might require more than one of these testers. You've got the technical subject matter expert tester, which is, somebody that is strong and knows everything about testing, that helps structure and decide the strategy, the test strategy of the product, maybe what should be automated, what not, and where are the business, the business criticalities or the technical criticalities, critical areas that need to be tested, and help and works with the rest of the team to make sure that testing is done in parallel, in sprint, very effectively. But then you've got the developer tester as well. And developer testers are the testers that like to stay in more of an IDE. They like coding. And when you talk about automation, they like to code the automation. They like to stay in their interactive development environment, maybe using and integrating in with some open source tools. And then you've got the business tester, who is somebody as a subject matter expert on the business side that normally, especially if you're doing testing for a packaged application, the business tester is the one that will probably, help define what test data, help you find and define the business data that is needed, that the business wants to run through the application, through the package, to make sure that it's working properly. And so you won't have just one of these personas, but you will have multiple of those, depending on the type of application that is being built. If it's a very technical application where the requirements are quite known, and you will have probably more of a development testers around that app. And but if you're more, as I said, doing business package applications, you might have more business testers. And the technical subject matter expert, I would say you always need one in an agile team, to make sure, as I said, and in your organization, more than one, to make sure that testing is done properly and that it's bringing the right quality that you need. Now, that's all stuff we've already shared, and actually I've even shared this in the past. I first time that I wrote about this was quite a few years back. But what's happening and what's happened is that only humans in the village won't cut it, right? We need more automation, we need more autonomy. And so what's happened is we've got these what we call AI infused bots that we call in Forrester TuringBots, and specifically there's a so-called tester TuringBot. And what a tester TuringBot does, we're going to come back in a minute. I'm going to explain very clearly what tester TuringBots do and why they are very relevant. But first, I want to share with you some data that shows how testing is starting to leverage AI more and more. You can see that between 2022 and 2021, those that are not using AI and machine learning and software testing, look at this bottom bar here, has halved, right? From 26% in 2021, only 13% said of 2,452 developers interviewed, only 13% said we're not using AI and ML. The rest are. And what are they using AI and machine learning for in testing? Well, for various things, for optimizing the test process, for testing AI infused applications. More AI applications are being used and deployed by customers. Somebody has to test those as well. They use AI for preventing and predicting incidents in production and so forth. But we're going to see many more use cases going forward. So I just wanted to share with you the fact that using AI and machine learning in testing is a reality. Okay, so, all right. Testing takes a village, but remember now, it's not just a village of humans, it's a village where you've got humans and you've got these tester TuringBots, as we call them in Forrester. Now, what do people expect out of these TuringBots? What do clients expect of, which we can say, what do they expect that AI will further improve and do better than what we're doing, that what we've been doing with the current tools and the current technologies and the current practices that we've always applied? Well, optimizing testing for better business coverage with constraints such as time and resources. I know of one very large European bank that built that tested their retail banking app for mobile, and because they, as you know, in mobile we keep adding and changing features and adding new features and new capabilities with multiple releases, in a week, and so they claim they didn't have enough time for doing all the testing that they wanted to do, but they only had a certain amount of time, budget, and resource. And so they built a model that helped them focus on the right and most important business areas. Every time they needed to do a deploy, the model would suggest what they should test, right? And optimize the testing with those constraints, respecting the time constraints. Further automate the process of generating automation. Of course, we can improve automation. Think about generative AI, how that's improving anything in terms of generating from text to generating also code. But today, it's still mostly manual. I mean, there's more than 50% of testers are still doing manual testing. So there's a big opportunity to do more there. But it's not just about automating the scripts and the test cases, but it's also about executing the automation, right? I did a little change. What is it that I can execute out of my test suite? Do I need to execute all of it, or can I just execute maybe what was impacted? Well, that's what good models and AI and a TuringBot can help you do. Help you focus based on a change. This is what you need to execute, and even based on a change, this is what you need to test. Eliminate redundant functional test cases that have accumulated over so many years. We know that AI does a really good job in natural language. So if I've got huge files of Excel files of test cases, and companies have hundreds of applications, and they've got also tons of Excel files with tests that they've built over the years, and because you've got hundreds and thousands of tests, it's very hard to kind of make sure, if you're just using an Excel sheet, which many organizations are, to kind of make sure that we still have the most optimal number of test cases and that we don't have redundancies. Well, running that through natural language, of course, we can identify the ones that are very similar and that can be cut, or maybe find out what ones we are missing based on the requirements. Identify how the application is used in production. We can have all that data and leverage that data and bring that insight back into testing to make sure we're testing the components, the features, the functionality that is mostly used, and that is therefore increases risk if we know that we haven't tested a certain area of the app that is highly used in production. And real insights into risk-based testing. So we all talk about risk-based testing, but we really are kind of depending on intuitions, right? It's a very ad hoc and naive approach that we use for risk-based, but instead with models and with all the data that we have, we can actually do a much more better and realistic risk-based testing thanks to AI. And basically test more with less, because we can test faster. So there's lots of cool, great things that customers, when we interviewed them, these are some of the things that those that are using AI in testing claim they're working on. And some of these things are more mature than others, but that's the expectation. Now, as I said, when I mentioned that I've been writing about this, and I wrote about this a few years back. Well, the few years back is 2019. That's exactly 3 years ago. And basically, these are the use cases that we came up with when we interviewed companies that were working with testing. It was really more system integrators working with clients back then. And these are, the use cases that we found out with different levels of maturity, as I said. But visual testing now has become quite mature. There's tools out there that do a really good job at that. API test generation, unit test code generation, automating the tests better, optimizing the testing, production, leveraging production data, insights from production that we can use to optimize the data, defect management, clustering bugs in production to reduce mean time to repair. And over the years, this is what we've added, because this is happening more and more. Optimizing regression test execution. As I said, I make a change. What do I need to execute? Self-healing. Self-healing is probably the one capability today that every vendor will talk to you about. Self-healing the tests, right? Self-healing the test case, the test suite, when there are changes that are basically throwing off your test suite. So TuringBots will become a reality for the entire software development lifecycle. So we started in 2019 digging deeper and diving on tester TuringBots. It was one of the first areas that in that research came out and jumped out from all the gurus we interviewed, saying, yeah, we think that AI and machine learning today, that's the area that probably we should start focusing on, because there's more opportunity and because there's a bigger need. What's happened in the meantime is the way TuringBots have evolved, the way AI has evolved. In Forrester, we defined and generalized the term of TuringBot to say that a TuringBot basically is an AI capability that supports developers and development teams during every stage of the life cycle of the software development life cycle. So there's theoretically and actually practically a TuringBot for each step. Right, you've got the design TuringBot, you've got a coder TuringBot that can help you code, you've got a tester TuringBot, you've got a deliver TuringBot that supports implementing DevOps principles or supports understanding the infrastructure as code that needs to be generated. And you've got TuringBots that can help you plan better your project, your product, and analyze it, right? And then you've got TuringBots that also make a really good job of pulling out of all the data of all those tools that are now in a tool chain and that are generating data and turning all that data into really strong insights on trying to drive your development strategy or your testing strategy. Now, what's also happened in the last 6 months, and we all can't ignore that, is generative AI. And generative AI really does add a further speed to the generation part, right? For the first time, AI is not just a decision tool, it's a tool that can help generate stuff. And that stuff is also code. So we've got generative AI now that can generate code for us. It can generate code across, and it could generate not just code, but also other artifacts and from different artifacts across the entire life cycle. So we're elevating that tester TuringBot that I was talking about to actually TuringBots that refer for Forrester as AI capabilities that support developers and development teams during the whole life cycle. And tester TuringBot is one of them. So let me review now but because this is about testing, I'm going to focus on the tester TuringBot, of course, right? So basically, a little bit of a formal description of what a tester TuringBot is. It supports business, SMEs, and developer testers to test smartly. Tester TuringBots help improve and augment functional and non-functional test automation, test graphical user interfaces visually and autonomously, self-heal tests, but not just self-heal tests or test suites as we do today, but it will also help us self-heal the code, find and fix the bugs, optimize the testing process and the test cases, generate close to real synthetic test data. Generative adversarial networks do a great job at that. Provide insights about the level of quality in code applications, and much, much more. There's a lot of use cases that are coming that we don't even know about yet, but these are the ones that we're starting to see. And so generative AI is really even further improving the concept of a TuringBot. And, you know, what is the underlying main technology of these TuringBots today are becoming more and more, it's all about neural networks, deep learning, machine learning models. But lately, we're starting to see the leverage, and going forward, we're going to see more and more the leverage also of generative AI, right? I mean, I'm going to probably share a little bit of an example around a ChatGPT and how it does even testing, right? And more than what has been done in the past. And normally these large language, generative AI is based on this technology of large language models that are based on huge amount of data, terabytes and terabytes of data, on open source data, on GPT-4. GPT-4 is trained on the GPT data set and other open source data sets as well. Some from vendors, some are completely open source. And there's a whole, in the testing space, the nice thing is, or the interesting thing for us testers is that there's a huge ecosystem of TuringBots, right? Parasoft is, and just to mention one example, since this is a Parasoft event, of course, is also infusing their own tool, have already infused their own tool with TuringBots, and there's more in the roadmap. I'm sure they will share that with you during the event. And if you look at the adoption, the technology evolution, meaning from an AI perspective, and the product ecosystem, the tester TuringBot testing is the one that has a lot of these diamonds in the intermediate phase. If you look at the other TuringBots in the life cycle, it's much less mature, except the coding TuringBot, which has also gained speed recently, thanks to, again, ChatGPT, but also some of the work that's being done also in the delivered TuringBots or the DevOps side of things. So TuringBots, right? When we defined it in 2019, generative AI was there, but it wasn't yet. I mean, it was starting to be a big thing, an important thing, and nowhere close to what it is today. And so I'm trying to kind of highlight what are the additional capabilities and how can we make better use of AI in testing. And it does allow the tester TuringBot becomes much more powerful with generative AI. So if you think about in terms of ChatGPT, you can see that you can prompt it requirements, and it's capable of generating code in 50 different programming languages. Actually, it's more than 50. I only listed 50 are the most important ones. But it can also generate not just the code, but the unit tests. It can generate, actually, then you can say, well, based on this requirement, based on the code you generated, which functional tests should I test, right? For testing the functionality, and it will generate the functional tests for you, but can also generate a test strategy, a test plan. So why can it do all these things? It's not because it does so in an intelligent way that means it it's like, like a human being. It's just because the way the technology is, it's been exposed to a lot of code and artifacts on internet, which also cover testing. And so it's learned about it, and so therefore it will be able to give you a good idea, a good recommendation, suggestion that you can leverage. But you, human, need to leverage, need to review, need to extend, need to fix. But it can get you started very quickly on that right now. You can also give it once, if you've got functional test cases, you can prompt it with a functional test case and say, hey, can you write the code? Can you automate it for me? Maybe because you told it that it could leverage tool XYZ, or it integrates with tool XYZ. ChatGPT has APIs. You can do that. You can also, so therefore you can optimize, not just take that test case and say, hey, optimize it, give me a better version of that test case, but also automate it. You can give it a test strategy, and you can say, optimize it. Is this a good test strategy based on these other, other information you have? You can give it the sketch of a UI, of a user interface, and it will generate the code for that user interface, but it can also generate for you the Selenium code to test it. Non-functional requirements, the same. I could go on and on and on, right? So there's a lot of opportunities. There's a lot of, let's say that, mainly improves what we're doing today, right? Definitely improving what we're doing today. And it will basically, TuringBots will, integrated in the platform that you're using, it will assist you more and more to use that platform, to be more effective with the platform that you're using. Or in general, as I said, because TuringBots are also, you don't just have the tester TuringBot, we've got all the other types of TuringBots. In general, they will be helping you in all those phases if you're using any tools. If the vendor has integrated in, TuringBots in the tool, the TuringBot will help you be more successful, use the tool in a much more effective way, and therefore achieve better results. Now, an interesting question, an observation that I want to make, also reactions from clients has been, well, I don't trust this AI generating code for me. Do I need to, or can I trust it, right? Or can I trust it and just be fast and it generates the code and I will put that in production? No, we don't recommend that. Actually, what the generative AI is doing is it's making testing even more important, because think about it. If you give a generative AI tool, Copilot or ChatGPT or Amazon Whisper or other coding TuringBots to your developers, you should first of all make sure that the developers that are using these tools are skilled developers, so they can look at the code and say, yep, this code is okay, it's good. Thank you for helping me out with some of this code, making sure that I'm using the API, the signatures, so that I don't have to go and look into a manual. Kind of autocomplete very quickly, write the code that you want to write, but you still need to review it. You need to make sure that that code is reviewed. And so over time, though, what might happen is that the developers might say, you know what, this is doing a pretty good job in generating the code. Do I still need to kind of really review the code and before it moves to the next step? Well, I would say in the normal world, do you still have reviews, or do you know that because you've got good developers, you don't do reviews? Well, normally, I think it was Amazon that told me they've got 5 steps of reviews before code gets shipped. So the point I'm trying to make is that for this to work, probably what's going to happen is we have to make sure that everything that is generated is also automatically tested, right? That's going to be very important, right? So all the AI generated code must be tested thoroughly, unit tested. We only do 50%. We can do better than that. Why would you write new code and not unit test it? But, unit testing is not, is not just the only type of testing. You've got all the functional testing to do. So I think that we have to make sure that the code, yes, will speed up things, will optimize and get very much more productive. Developers on coding can get basically 50% productivity gain in using TuringBots. But we may have to make sure that that code does get tested thoroughly, right? And so it has to be automated. You write the code, it gets tested. You integrate the code, it gets tested. You finish and you want to do the integration testing, gets tested. And so you also have to run your security checks. The code that the bot generates, right? It's code that it's learned. I mean, it's learned from all this big, large language models, which is the code that exists out there. Is it all perfect, secure code? No, it's not. So it's going to have the same level of security that maybe the average good developer would write. And so you still need to run your security checks, SAS, DAST, and so forth. You still have to test the speed of what the TuringBot generated, the coding TuringBot generated, or the load performance. So basically, the tester TuringBot is kind of a twin, a digital twin, has to be a twin, not a digital twin of the coding TuringBot. In other words, they have to collaborate and work together tightly, side by side, so that everything that gets generated also gets generated and tested by your testers, by the tester TuringBot. Now, there are some risks about all this, right? This is exciting. This is the world we're going to, we're going to be working with TuringBots going forward. We're already starting to work with TuringBots. And I can only thank ChatGPT for one thing, which is at least it's created a bit of enthusiasm and it's giving a push, because I've been writing about this since 2019. And we wrote about TuringBots in 2020, 21. And 2022 was, I guess, I could call it the breakthrough. Now, but we don't ignore the concerns and the risks, right? Questions you might have and you should have is, how is my code and data being protected in the cloud? If you're using ChatGPT or Copilot or some of these tools that basically process from the cloud, the data is being uploaded up on the cloud, and so that's a concern. What data was the generative AI TuringBot trained on? GPT-4 has been trained on a huge amount of internet data and GitHub repositories and all the repositories that exist out there. Was all that software permissive open source licensed software? IP protection, software attribution, monetization recognition, right? If I'm learning based on software that a company has written, or I'm learning all the training from the training books of a certain product, and then as ChatGPT, if somebody asks me, what training class would you develop for product XYZ, which is, the one from which we trained the original ChatGPT on, is there some IP protection breach there, or maybe not, but maybe there's an agreement I need to make with a vendor that contributed it, something like, something like, basically, I'm giving you my IP, you're using my IP to do things better. Should you recognize maybe some license to me? And software attribution, if it's open source and it's using software, again, it's using all that open source out there, shouldn't it be attributed if it's learned on that software? All these are, issues and concerns right now in the market. And we know also that these large language models are non-deterministic, meaning that when you might give it a prompt and it gives you an answer. You give it the same prompt, it might give you a slightly different answer. But it also hallucinates. In other words, it gives wrong mistakes when in some cases. Also, can the company coding and testing policy, how can I apply my coding policies rather than the ones that the TuringBot learned, if it's using, if it's based on a large language model that it learned out there, in the wild? Can I customize that foundation model on my own code repository so that I can use the same coding and maybe test strategy as well? How secure are the TuringBots? Can I make sure they don't breach my security rules? How frequently does the TuringBot get updated? If it's based again on large language models, and with what costs? Now, as I said, generative AI is the recent new technology that's coming out there, but AI, the tester TuringBots are built also of machine learning models and other techniques that are not necessarily relying on generative AI. These are some of these questions become particularly important when you're using and leveraging generative AI, of course, right? I just want to make sure that's clear. What governance and new development and testing practices and skills are needed for working with TuringBots? That's a serious question, right? Do we need maybe some prompting skills to make sure we're prompting the TuringBot better, and also some fear of losing the job? Actually, this is interesting because GitHub did a really interesting survey on Copilot, and actually the developers love it, right? Because they think that the TuringBot helps them save a lot of time. And that's what I would say AI does when we're leveraging them in the software development lifecycle. Okay, so let's wrap it up, right? So yes, there are these concerns, so you have to be aware of them, but it's your job, because the more, generative AI and AI won't be successful if we're not able to test what the AI does. So we as testers, your job as testers is to make, is very important to make all this happen and to leverage it. So you should energize your testing modernization program with AI across people, process, and technology. So experiment and familiarize with tester TuringBots, being aware of the risks. Evolve your testing technology towards a platform for multi-type, multi-persona testing. That's going to be critical. 3, enhance your test automation technology with TuringBots for faster, better, and autonomous automation. So we have to increase the level of automation. We have to disrupt what we've been doing so far, and embed developers and development teams piloting generative AI as well, because generative AI is not going to go away, right? We have those challenges. Those challenges are going to be solved. It might take, more to solve the challenges from a governance, from a practice perspective, but the technology is moving really, really fast, faster than what we think. So with that, I thank you very much. Enjoy the rest of the conference, and thank you, Walter and team for having me.